everybody, welcome to writing equations from graphs. Today we're going to write equations of quadratic functions, and my biggest suggestion here would be to write your equations in vertex form first, or try that way first if you know the vertex. That's well established. If it's decimals and you know the exact decimal, maybe it's half or something like that. But if it gets a little more complicated, you might have to use standard form or vertex or factored form. But today I'm going to focus on vertex form, and maybe I'll throw in an example of factored form at the end. All right, so we know that vertex form takes this shape. Okay, where h and k is our vertex. Now our vertex in the first graph, it's opening down, is right there. So in the first example, I know my graph, my a value has to be less than 0, or it's got to be negative. I'm also going to pick a couple points that I see exactly on my graph to help me out. So the first thing I'm going to do is I'm going to substitute the vertex. The vertex is 0, 3. Okay, so let's go ahead and substitute that in. So I have y equals a times x minus 0. Now, do you have to write that? No. And there are other ways to find your a value and things quickly, but I'm just going to do it this way. Okay, so I substitute in 3 for my k value because it's a shift up. And let's just rewrite this without the 0 now. We don't need it. Okay, and we're almost done. So we have y equals a times x squared plus 3. And so you have 3 unknowns there. You have an unknown y, an unknown x, and a. We have to find a, so we have to use one of those other points that I talked about at the beginning, that I marked off. I'm going to use 1, 2 here because both values are positive. I can use any point on that graph. It just so happens I'm going to use 1, 2. So my y value is 2, and then my x value is going to be 1. So I'm going to plug that in. So I have a times, it's going to be 1 squared plus 3. And now I simplify this equation. So I have 2 equals a plus 3. And now I just subtract 3 from both sides, and I get a equals negative 1. And it should be because my parabola is opening down. And so that equation, you can use this part right here. You have y equals negative a, okay, times x squared plus 3. That shows the graph shifting up 3 units and flipping over. So if we look at our second graph, it's also opening down, so the a value is going to be negative. So I encourage you to pause here and try to write the equation yourself. And I'm going to go ahead and go do it. So again, I have y equals a times x minus h squared plus k. Our vertex is 3, 0. It's a shift right of 3 units. So we'll have y equals a times x minus 3, even though we move to the right, it is minus. Remember, it's opposite there, squared plus 0. In this case, there's no k value. There's no shift up or down. So I can rewrite this as y equals 9a squared. Or excuse me, not 9a squared. We can't rewrite that. We're going to have it just as a times x minus 3 squared. There we go. I got confused there for a second. So I need another one of my points, and it looks like I'm going to use 4, negative 1 right here, because I have to find my a value now. So 4, negative 1. Okay? So y is negative 1 when x is 4. So you have a times 4, so 4 minus 1 is 3, so you have negative 1 equals a, right? 1 squared is 1, and there you go. And now we have y equals negative x minus 3 squared. That's the equation for that one. Okay, so if we continue on, I've got 2 more examples here, and what I can tell you is that on this example we could use factored form on either one of these. I'll probably do factored form for the last one because I can see the 2 zeros nicely. Okay, so we're going to go ahead, and you can try to race me on this one to see if you can beat me. we're going to go ahead and we're just going to, A is going to be positive, so my vertex here is -2, -1. So that's going to look like x plus 2, right? Because you moved it left, so it's plus in there, squared. And remember, h or k is what you see is what you get, so that's a -1 there. Okay, now I've got to find a, and I've got some other points, and I've got this -1, 0, one of the intercepts. So I'm going to go ahead and use that one to find my a value. And I'm going to go ahead and plug in 0 in for my y value, because it is a y-intercept at -1, 0, equals a times my x value is -1 here, so -1, whoops, plus 2 squared minus 1. So I have 0 equals a times, well, -1 plus 2 is 1, 1 squared is 1, so I have a minus 1. So in this case, a equals 1. And no, a is not going to be always 1 or -1, it's just these examples that I picked. So now I have y equals a, which is 1, so I can just leave it as x plus 2 squared minus 1. And there you go. Last one, you can use factored form, okay? And there's my vertex because I have zeros, and I could have used it here too. Remember, factored form is y equals a times x, like plus m, and x plus n. Now those could be minuses too, just depending on where the zeros are. In this case, they will be negative. So we have y equals a times, well, one of my zeros is plus 2, so that means it's x minus 2 here. Then my other 0 is 4, so it's going to be x minus 4. Remember, zeros have opposite signs when they're than factors. Okay, so I got to find a. And guess what? I use another point. Well, why not use the point 3, -1? So I can plug in -1. So look, 3, -1. That's the vertex. That's another point on my graph. -1. That's my y value. Equals my x is 3. So you're going to have a times 3 minus 2. Right? 3 minus 2 times 3 minus 4. Okay? Simplify that out. You get -1 equals, well, a times 3 minus 2 is 1. And 3 minus 4 is -1. So you have -1 equals -a. So a equals 1. Okay? That equation is just y equals x minus 2 times x minus 4, because your a value is 1. You could multiply that out and get standard form, and that's another easy one to get from there. Or I could have written this all in vertex form, but I just wanted to show you a couple of examples there. So if you have any questions or comments on how to write equations of quadratics, you can type them below. We'll see you next time.